Okay, so first we're going to talk about, before we talk about add, subtract, and multiply complex numbers, I just kind of want to give you guys a brief description of what they are. So first off, complex numbers have two parts. Okay, so they have a real part and they have an imaginary part. So a lot of times your complex numbers are going to look like an ordered pair, but the only difference is that they're going to have an addition or a subtraction sign in between them. So 4 plus 3i. This part right here, that is the real part. Okay, that is the real number. And this part right here is the imaginary number. Okay, so just like if we were to have the ordered pair 4, 3, these each go on their separate axes. So this would be on my x-axis, this would be on my y-axis, and I would look for where they intersect. So this is x, this is y. So if I'm looking for 4, 3, I go to 4 on the x-axis, and then I go up 3 on the y-axis. So this would be the point 4, 3. So we graph complex numbers in a very similar manner. There's just some very slight modifications to our axes. So instead of this being the x-axis and this being the y-axis, this is now the real axis, and this is the imaginary axis. So this would be 1, 2, 3, 4, and this would be 1i, 2i, 3i, 4i. So if we were going to graph this number, 4 plus 3i, we would do the same thing. On the real axis, we're going to find 4. And then because this is a positive 3i, remember all the imaginaries that are positive are going to be above the x-axis. So we're going to go to 4 on the real axis, and then we're going to go up to 3i on the imaginary axis. And so this is going to be the complex number 4 plus 3i. So notice the real part always comes first, the imaginary part always comes second, and there's either going to be a positive or a negative in between those two. So if we wanted to graph the complex number -3 minus 5i, okay, we would first go to -3 on the real, because here's your real number, and then we would go down to 5i on the imaginary. And so again, these would be -1i, -2i, -3i, and so on. And so this would be the real, or the complex number, -3, -5. -3, -5i. Okay? So this is how we graph complex numbers. Now, if we were going to add complex numbers or subtract complex numbers or multiply complex numbers, this is going to be very similar to how we would add and subtract and multiply binomials. So okay, so let's say that we want to add 3x plus 2 plus -5x plus 6. Okay? So we're going to add these two together. So the way that we would do this if it was binomials is we would find the parts that are similar, the like terms, and we would combine those parts together and then combine the other like terms together. So if we look at this one, we can see that these are like terms because they both have the x's. So really what we're doing for that one is 3x plus a negative 5x. Okay, then for the other one, these two would also be like terms because they don't have the variable at the end. So we would also have 2 plus 6. So when we add these two together, we get a negative 2x. And when we add these two together, we get a positive 8. So we've taken these two and we've basically combined them into one binomial, okay? Complex numbers work the exact same way. So if I were going to add 5 minus 7i plus negative 1 plus 4i, we would do it the same way. So we would look at, okay, where are my real numbers? So the real numbers would be these right here. So we would do 5 plus negative 1. And then we would do the same thing for our imaginary numbers. So our imaginary numbers would be negative 7i plus 4i. Okay, so when we add these together, 5 plus negative 1 is 4, and negative 7i plus 4i is negative 3i. So we take two complex numbers, we add them together, and we get one complex number. So it should still have the same format as the original two that we started with, just different numbers combined, simplified. Okay, so subtraction is really just addition in disguise. So I'll show you what I mean with that. I'm going to kind of slide these over here. Okay, so let's say that we want to do the same thing. We are going to, instead of adding this time, we're going to subtract. So we have 5 minus 7i minus negative 1 plus 4i. So the only difference between addition and subtraction is that we have to take this and treat it like a negative 1. So this is going to get distributed through to everything inside here. So negative 1 times negative 1 is positive 1. And negative 1 times positive 4i is negative 4i. The subtraction sign is now going to turn to addition, and that first complex number is not going to change at all. So all we've done is we've taken the subtraction problem and we've turned it into an addition problem. And then we do the exact same thing that we did in the last one. So we want to combine the real terms. So we have 5 plus 1, and then we want to combine our imaginary terms. So negative 7i plus negative 4i. So when we add these two together, we get 5 plus 1 is 6, and we have negative 7i plus negative 4i, which is negative 11i. So we started off with two complex numbers, we changed it to addition, added them together, and we got a new complex number. So again, every time that we start with two complex numbers, whether we're adding, subtracting, or even multiplying, what we're going to end up with is another complex number. So in the last one, I'm going to show you how to do multiplication. Okay, so we'll just do the same two complex numbers. And I just want you guys to notice the difference between these. Okay? So this has an addition sign in between the two of them. This has a subtraction sign in between the two of those sets of parentheses, between those two complex numbers. There is no sign in between these. Okay, so you have to pay attention to whether you're being asked to add, subtract, or multiply. All right, so we'll just do 5 minus 7i times negative 1 plus 4i. So if you can remember how to multiply two binomials, you should be okay with multiplying these two complex numbers. So I'm going to show you a couple of different ways that you can think about this. The first one is using that area method for middle school. So one complex number is going to go either across the top or down the side. You can't split it up and put part of it up here and part of it over here. They have to go on the same side. And it doesn't matter where you put it. Okay? And then the other one is going to go on the other place. So if you put the first one on top, you have to put the other one on the side. So this is negative 1 plus 4i. And then just like your Punnett squares in biology, you're going to do the same thing. You're going to multiply. So you're going to take this and multiply it times everything up here. So negative 1 times 5 is negative 5. And negative 1 times negative 7i is positive 7i, and I recommend putting the signs in with that. That will be very helpful. And then we're going to do the same thing, but we're going to do it with the bottom number. So negative 4i times positive 4i times positive 5 is positive 20i. And then this is the part that gets a little tricky. So you have positive 4 times a negative 7 is a negative 28, and you have I times I, which is I squared. Now in the previous video, we talked about I squared. I squared, remember, is the same thing as negative 1. So really what you're saying here is negative 28 times negative 1. So this I squared is actually going to go away, and it's going to change the sign on that 28. So if it was a positive 28, it's going to change to a negative. Since this one was a negative 28, it's going to turn to a positive. And now all we have to do is just combine our like terms, just like we did over here with these addition ones and with the subtraction ones. So we have negative 5 plus 28, and we have positive 7i plus 20i. So when we add the real ones together, and remember we always put the real ones first, negative 5 plus 28 is 23, and we have 7i plus 20i, which is plus 27i. So again, we started off with two complex numbers, and we ended up with one complex number. So there shouldn't be any I squares. It should be a real portion and an imaginary portion when you multiply.